All right, Internet, welcome back. We're on a roll. We are on a roll. So this is, we are doing Natas 14 and 15 today. 12 and 13 were yesterday, and 13 was a beast. This time around, it was pretty difficult. I learned a lot, and that's always fun, and a good thing. So 14 was surprisingly easy. I think I got lucky because I've actually seen and read about SQL injection, which is really what 14 and 15 are all about. 15 is more complex because it's a different type of injection, but 14 is a very basic SQL injection. So what I'm going to do here is I'm going to show you kind of at a high level what SQL injection really is. And in the back end, we have our SQL database, right? So that gives away the whole concept, right? So we have a database here. And in this database, let's say that we have two columns. One has users and one has passwords. And for each of these, we have a series of inputs, passwords, and usernames. And then we have user space over here. So this is going to say this is user space with our evil villain. And in between, there's a website. And this website, if I can make a W, takes some sort of input, which is going to be both the username and password. So these two fields, they're pretty important, right? And the reason they're important is because this goes back to the point that we made in the previous video is in userland, you have the ability to basically inject anything you want if there's an input available. So you can try it really out. You can try anything. And depending on how funky you get with the injection or the input that you put into this machine, that correlates directly to the output that you get or the access that's derived. Now with this specifically, the SQL injection, the two parts we're coming in here are the user and password here. So we'll zoom in a bit. Let me do this, do that, and we'll undo. So with that being said, if we can input anything here, and our SQL database here has a bunch of stuff inside of it, then maybe there's a chance that depending on what we input in these fields, we might actually be able to get more out of this database than what's expected to be given. And the reason this database really exists for this username and password is when you put the username and password in, the job of the website or the machine in the center is basically to do a correlation match. So if you put in user 1 and password 2, what they're going to do is they're going to say, okay, is username 1 in here? And if username 1 is in here, then I'm going to basically check the password 2 in this column, and I'm going to ensure that password 2 correlates directly to user 1. So if we do this piece, that's good. Like we've done the correlation, we've said, okay, you're authenticated and you have access in here and you can see what you want to see inside of this, this special place inside the website. But like I said, if you put in something magical in there, you might actually get back more. And that really comes back down to sanitization of the input that you're deriving and a few other things. So let me show you some areas that I've gone to first initially when approaching this. So actually I first went to the source code as usual, and you can see the source code links here. And if you go into the source code, you can see a few different things. In a nutshell, you can see that there's a query here, which is really the largest part of this entire code base, and the most important thing really to look at. And you can see what they're saying is they're basically stating that they want to select anything from users, which is part of the table, where username equals the request, which is the username we're inputting. And then they're going to look for the password equals the password we input. So these are the two columns. So we have username column and password column. We're going to put in our inputs for each of those, and they're going to go back and do a correlation and pull out that information if it's there. And you can see that they can say successful login, the password of Natas, etc. And then you can say access denied if your access is denied and you put in the wrong thing. So if we come back here, we can say, okay, if we put in Bob and Bob, access denied. So Bob is not a password. But with that being said, like I said, there is no sanitization here. And we know that because there are no additional functions or parameters stating that they want to sanitize the input that we're putting in. They're taking directly what we've given. And you can tell that by the request, the global request variable here. And that's stating that basically they're taking anything that they've requested from us. So if you just type in SQL injection, you'll usually come across a series of websites, two of which I found quite useful. This specific website is really good with a lot of stuff. Web3 Schools. And they actually walk you through some examples of SQL injection. And when you look through here, there's a few different options. Here they're basically talking through some examples of what an SQL query looks like. So when you're doing an SQL query for an SQL database, you can get back certain information. Below here you can see some examples. So here specifically, what they're doing is they have two statements here, right? So they have user ID 105 and they have or 1 equals 1. And what's happening here is basically with the OR logic, so this Boolean logic of OR, if either of these are true, then everything is true. So 1 equals 1 is always true. 105 is almost irrelevant because the interpreter is going to basically check 105. It's going to see that it's incorrect. Then it's going to go to OR, and then it's going to check 1 equals 1 because that's part of the SQL queries. SQL has OR as an option inside of its query language. So if 1 equals 1, then it's true, meaning they're going to give you everything back. And if you go back down a bit further, so I actually tried this one. So if I put this in here, you can see that it doesn't work. So if I put in this, no dice, maybe if I do Natas 15, we can try that. Access denied, no dice. So neither of those worked, and I realized that wasn't the catch. So you keep reading this website, you can see there's alternative methods as well. So if I go back further, you can see that there's another option here. And this additional option is actually checking for username and password. And what we're doing here is we're actually going to access the usernames and passwords in the entirety of the database, and we're going to try to pull everything back. And the reason we're able to do that is you can see somewhat of the results here of what that would look like. So if I scroll down a bit, the code in the server and what the database is reading back from what we provided are these little bits here. So we can see basically that what we're saying is basically quotes or quotes equals quotes. So quotes is like empty space. So empty space or empty space equals empty space, which is always true. And the same applies for the password here. And we're doing the same thing here. We're basically going to take this and do exactly what they've done. So we're going to basically cheat and copy them. And if we copy and paste that into this username and password, you can see that when it comes back and it says success, you've succeeded, you've gotten your password for the next level for Natas 15. One other thing on SQL injections is I actually found this website quite useful. It doesn't necessarily talk about the specific example that I provided to you right there with Web3 School that gives you the answer, but this gives you kind of a broader overlay of SQL injection more broadly and the different types of injections that there are. Highly recommend this video. I think it's only 10 or 15 minutes. It's really, really insightful. And it's really actually interesting to think that there's so many different types of SQL injection instead of just the basic one I've just shown you. So this is the one that we've done, retrieving hidden data, where you basically put in some sort of malicious input, and that provides usually the database back to you or some access to the database you shouldn't have. Another one is retrieving data from, I'm trying to find one that really jumped out at me. I think it was this guy. Second order SQL injection. This is the one I was thinking about. So this one's really interesting, and let me try to find the specific sentence of what it explains and kind of why it jumped out. So this is it here. I'll zoom in a bit to hopefully explain it in a way that makes sense. So what's happening here is that the malicious actor is actually inputting malicious data, but the developers have done a good job. So if you come down here and really read this sentence here, the developers have done a good job and they've sanitized the data. So here they can say that they've safely handled the initial placement of the input from the bad guy, right? So they've taken that input. So we have our bad guy here, and they have our website and then our database, right? So our bad guys put malicious data in here, but luckily our developers have done a good job and they've actually sanitized that input. So they've taken that input and they've placed that into the database. But the issue here is that this wall between the website and the database becomes, this is protected and everything that's input in here is labeled malicious and they don't trust their user input. But once it passes this barrier and gets put into the database, then it's basically deemed safe and the input is okay. But the code is still malicious. So what happens over time is actually when this data is processed, when it's sitting inside of this database, then it's actually deemed to be safe. So you can see that previously placed in the database safe, blah, blah, blah. At this point, the data is handled in an unsafe way. and because the developer wrongly deems it as trusted. And when they state that it's handled in an unsafe way, is once that malicious input is in here, then it actually executes some sort of code and then kind of dings the actor later. And I think that's partly why they put a little phone here. So basically the actor has put in some malicious code. So let's scroll up a bit here, clear that out. Say the actor has put in some malicious code here inside of this create account, and that create account then goes to the profile, it's created the profile, and then the malicious code is still here. And then basically it's stating that later on, once that code executes, so you can see that it executes here, it notifies the actor via their phone or whatever else, and then they can actually gain access into the website later on. So it's kind of like, it's like passive investments. Like you invest all these malicious code or input into all these different websites, and then it kind of just reaps its rewards over time. So I thought that was pretty fascinating. So that is 14, right? So 14 out of the way, we are going to go on to 15. And 15 does include some code. So 15, you can see that we're starting out with just a username, no password. And whatever you put in this username, it's not necessarily providing anything back. So it's not telling you your username or your password. It's not giving information back. It's only giving you a Boolean value of saying it exists or it doesn't exist. And you can see that by this button here that says check existence. So if I type in DDD, put that in, the user doesn't exist. But if I put in, and now this was just a guess to say, okay, we're on Natas 15 and we want to get to 16, you can see that the user does exist here. But with that being said, that's really all you get back. Either exists or doesn't exist. And you can actually come to the code here and look into it, and you can see the different options that are provided back. One alternative option that is provided back, so you can see right here it says the user exists is one option here. User doesn't exist is the second option, and the last one is error in the query. So if you try to put in some sort of malicious code, that's kind of what you get back. Is there is some sanitization, not the most, but you get 3 basic options, and it's kind of obfuscating what it wants to give back to you, so you're not necessarily hacking into anything by over explaining an error message to the user. So when looking at this, honestly, I had to cheat. Definitely had to cheat on this one. And when looking at this, you can see it's somewhat similar. So we're selecting for anything. We're looking for the user, where the username is the request. So there's not much sanitization there, which is a good thing for us because we can input some sketchy stuff. But next, this is the crux of it. We have no password and we only know the username because we've guessed it. It's Natas 16. But luckily, they've actually shown you what the table and how the table is structured. And it's very similar to what the structure was that I showed you previously. So basically, we have our table, and in this table, if I can draw a square correctly, we have a username, right, which is correlated to this, and then we have a password. So all we have is the username, and all we know is that it's Natas 16. We don't know what the password is, and it's not going to provide us the password back. It's only going to say that if an item inside of this exists or doesn't exist. So that's going to be kind of the trick to this one. So the trick here is that we have our username and we have to find out our password, and we see that here that the password is going to have a potentially 64 characters because there's a varchar function of 64. But if you previously think about the last challenges that we've done, all of those passwords have had 32 characters, not 64. So that's kind of a tick off in our head, and that's something nice to know. So the next thing is I cheated, and I looked at these 2 tutorials here to kind of see how they approach this. And you can see that what they've done is they've basically written a short Python script, and that short Python script is going to do a really small thing, and I'll actually draw this on a separate page that's not so distracting. So this is a kind of somewhat of a blank page. So what the Python script's going to do here is basically it's going to take the 64 characters, should be 32, and it's going to continually check against the password. So we have our username, which is going to be Natas 16, right? And then we have the password that we don't know. But what we're going to do here is we're basically going to take a series of characters. So we're going to do A through Z lowercase, and we're going to do A through Z uppercase, and then we're going to do 0 through 9. And we're going to take all these characters and we're going to run them, and we're going to brute force basically this password, and we're going to check every single one. And we're going to say for the password for Natas 16, does it include this character? If so, put it in this list over here. So this will be our list of potential characters, right? So we'll say list of P. And if it exists, then we'll bring it over here. If it doesn't exist, ignore it. And what we're going to do is we're going to check this every single time. We're going to run it over. So we're going to say Natas 16 A, Natas 16 B, Natas 16 C, Natas 16 17 or C or D, whatever. And we're going to keep going through that. And if it has a C, and if the C is lowercase, and it realizes that, then it's going to throw it into this list. And then once we've built this list out, then we have a list of characters that are in the password. We don't know the order of them, but we know that they exist in the password. So the next function is basically going to iterate over this list, and then it's going to run it back against the password. And then it's going to ask, is this character in this location? So is lowercase a in location 1? If so, then good. If not, then pass. Then we'll go to B. Is B in location 1 in lowercase? And if it says yes, it will say okay. So then we'll actually add that to another list, which is going to be our password. So we have our password on another list. And this list is going to basically simply contain, we'll have B, right? B is the first one we found. And location 1. We're going to go through and it'll say all the way through the alphabet or the list that's inside of our list here, and it's going to say okay, is 1 in location 2 or location 2, and it says yes. So then we'll have 1 here. So then we have B, and then we have 1, and we're going to slowly build out our password over time as we iterate through these two functions. So this is something that I found very fascinating, and these two blogs did a really good job at explaining it and providing some insights into this. I highly recommend actually this blog. I'll go to the top, Natas Level 15, Hammer of Thor. It's on a GitHub page. And the reason I've actually recommended this one is because this individual does a very good job at explaining specifically how they've written out their Python script, the purpose of the script, and why it exists, and what it's doing. So I'll walk you through some of the code because I've kind of read through it, understood it, rewrote it myself, basically copying and pasting and like editing little items, trying to figure out how it works and how it functions. But before I do that, I actually want to explain what we're doing here, because this isn't just a basic SQL injection. This is considered a blind SQL injection. And this is OWASP, right? So I'm sure you know OWASP is. Blind SQL injection is one of the more advanced SQL injections. And you can see I recommend kind of checking this page out. It walks you through kind of the basic description of what it is. There's actually some examples down here. It explains that there's time-based. There's variations of blind SQL injections. And remote database, fingerprint, time-based. Which one did we use? Content-based might be the one that we gave. But either way, this is useful. And also there's a series of other information here. So I highly recommend checking that out. And with that being said, I'm going to take you into the code of this Python script. So I actually have two Python scripts. So I have one Python script from this individual, Hammer of Thor, that did the good explanation. And then I have the other one from the Apache blog, which we've used in a previous level, where this individual basically gave the Python code for their way of approaching it. And the reason I actually have both is because the Python code from this blog, from the Apache one, is that it's in Python 3, and then the Natas Level 15 is in Python 2, obviously because it's written in 2015, so it makes sense. I had to reformat some of the Python 2 to Python 3 because that's what I write my Python in, and even though there's small differences, it's still somewhat convoluted and confusing. But either way, highly recommend this one first, and then using the Python code from this one. So what I'll do is actually I'll talk you through some bits of the Python code in the second one, and actually this one's a lot faster too. So the Apache code, I ran both. So I ran the initial one from the Python 2. It was very slow, and this one was a lot faster. But either way, it was still useful. So let's walk through some of this code, and I'll kind of give you an explanation of what's happening here. So first off, first things first, we have to import a series of modules, because that's what everybody does in Python. And this module here I've not used before, or this method inside of this module specifically. And I'm actually going to change the coloring on this because this screen's dark. All right, hopefully this looks a little better. Yeah, it does. Oh yeah, so much brighter. So this method inside of this module I've not actually used or function. Basically what this is doing is it's doing additional authentications into the website. So let's kind of break this down for a second. So there's a few things in the beginning that we need, right? So we have the series of characters that I mentioned. So this is going to be basically a series of ASCII characters and digits. The ASCII characters are going to be the uppercase alphabet here, the lowercase alphabet here, and then, like I said, 0 through 9 here. These are the digits. And this is going to start off our character. This is kind of like our brute force pool of data. And we're going to run this pool of data against the website, checking the password characters and seeing which ones exist. So once we found out that one of these characters exists in the password, we don't care about the location at first. Then we're actually going to drop that character into this next string. And this string is going to be filtered. That's what we're calling it. So this is basically the filtered characters that exist in the password. So once we have this series of characters, which should be 32 characters, remember that, not 64. So this is going to be 32. Then we're going to take this and we're going to organize it and figure out which locations are which. And then that's what you're going to do here. You're going to take those characters, you're going to order them based off of checks. You're going to check them again. But this time you're only going to check these 32 that you have. You're going to run through different iterations. And then once you've gotten that, you're going to order them. And then you finally have your password here. So that's the first chunk, right? So we have our different lists. And then we have two larger functions. Or for loops, which should probably be bundled in functions. But this is a for loop, and then we have another series of for loops here. So this for loop is going to basically find out our filtered piece. So filtered is going to go to this for loop here, and then our password is going to go to this for loop. And that's how the order is going to be for each. So for this one here, there's a few things that really jumped out to me that I really needed to dig deeper into and learn more about. Specifically, you can see that this specific for loop has a series of characters. So we're going to basically loop over this list of characters. We're going to find out, we're going to go through each character in here. Once we do that, we're going to take the character we've run over. We're going to put it inside of this, basically this URI, which is an addition to this. So you can see that data here is going to be plugged into this value here for this key of data. And then this is going to be attached to this R variable. So the post is going to be basically this URL here. And then we're going to actually have the authentication. So we're going to, this function is the one I mentioned up here that I've not seen before. What it's happening is basically re-authenticating every single time to the website. So it's putting in the username of 15 and then the previous password we found. Then it's going to attach this data piece here on top of that authentication and to create a URI. And that URI is going to contain a series of interesting bits here. And the interesting bit to this URI specifically is the SQL functions, I think, or methods called like and binary. So these are two things I had to research. And I'll quickly take you to two interesting websites that actually helped me understand this better. So this specific one is Post. Why did I pull Post up? Wait, 1 second, internet. Post. So I pulled it up because I wanted to understand more about the post request. And then I wanted to specifically understand more about this authentication key because I needed to learn more about this specific function. But like I said, it's just re-authenticating into the website. So we don't need to worry about that one. But this one, this is the moneymaker. So this is the website for MySQL that explains these specific items that I wanted to learn more about. And here you can see it's talking specifically about like, and then we also have binary. So first we'll start with like. So like is a simple, I think it's a function, there you go, a comparison function. And what this function is doing is, like it states, it does a comparison. So it's basically saying, is A like A? You know, are they the same? We'll do 2 equals for equals, right? Are they the same? If they're two like this without anything else, if it's just a like function, then this is obviously going to be yes because they're 2 lowercase a's. But the interesting thing about the like function is that if you have a lowercase a and an uppercase a, it considers it the same because it's actually case insensitive. It's not considering the casing. And that's something that we care about with our password. And that's part of the reason why they've included binary. So if I scroll down a bit further, and actually if I just type in binary, it'd probably go by faster. I can't do it, internet. Binary. All right, let me go down a bit further. There's a specific part in here. Here, this is what we needed, this sentence here. So in this sentence here, basically what they're stating is that it shows different types of ways to do comparisons between 2 characters when case sensitive actually matters. So here you can see that basically it uses the collation, a binary string of two items. So what the binary function inside of MySQL is doing, it's actually changing the character into a binary string. So it's taking the character of lowercase a and turning it into its binary format. It's taking the character of uppercase a and changing it to its binary format. And if you go to this website here, W3 Schools, they actually show you specifically what it looks like. And this is actually what made it click in my head. So if I scroll down a bit, you can see that it basically tells you what it does. So a calculate a value to a binary string. So we're going to take this value here, we're going to calculate into a binary string. You can do the try it yourself, run the SQL. and it's basically going to give you back a number of ones stating that it's been converted, which is insightful, but not exactly what we're kind of looking at. So if you go a bit further, you can actually see where it explains the importance of this and how it's used. And this is the example that actually really resonated with me. So you can see here that they basically state the example of hello, hello, this returns 1, if you're just doing a like. But if you go down a bit further and you add the binary function to that, if you're not just doing the two comparisons, the binary actually comes back and states that it's not equivalent. And it's not equivalent because, like I stated, it turns it into a binary format, which capital and lowercase are different. So I beat that horse to death because I thought it was super interesting. And it actually helped me understand more about this code and why it actually works. And if we come back in here, that's what the binary piece here is for. So what we're specifically doing is we're doing a like comparison. So the first thing is we have to do a comparison, but the comparison we're going to do has to be in binary, and it's going to be for this character. So this could be A, this could be 1, this could be uppercase A, it could be really anything here. And then we're going to iterate through that. And as we iterate through it, like I stated, it's going to come back and it's going to build out this dictionary of filtered characters, right? So we've gotten through our first function here. Now the next thing here is you can see there's a range of 32, and the reason that the range is 32 is because we already have our 32 randomized characters that we need to order now. And now the next thing is we're going to actually filter through the filtered list. So we're actually going to iterate through this list that we've already created. And as we iterate through that list, we're basically we're gonna build it out over time. And as we build it out over time, so say that we already found out that A exists, we found that 1 exists, and we found out that capital Z exists. So this is the 3 characters inside of the 32 character password that we've already figured out, and we know the locations of those. So this is location 0, 1, and 2. Now this is going to be equal to our password here. And we're going to build on this over time. So now we're going to do another check, and we're going to say, okay, is B in there, lowercase b? If it is, then I want you to add it to this password list. And that list is actually the one that we pointed over here in this list. So as we're building this out and iterating over it, you can see that we're doing the similar situation where we're actually going to keep hitting that URL, that URI over and over, and we're going to keep checking this. And as we check it, we're going to build it over time. And what we're checking for specifically is that if if exists, so the if exists piece is basically coming back. Remember how we put in the username and it said this user exists? So we're reading that text on the page because you can see that basically we're requesting this R and we're reading the text here. And when we read that text, we want to make sure it says exists and does not exist, right? So if it does, then we're going to actually add this character to the password as well as this character to the filtered list. So as we add it, then we're going to eventually print it out over time, and once we're done, we'll break and we'll have our whole password. That was a lot, but I thought it was interesting, and I actually understood it, which I thought was crazy. So I'll run this, but I'm not going to sit here and have it iterate over time because it takes way too long. But internet, let me drink my tea. Alrighty, so what this is doing is taking forever. But as you can see, and the reason it's taking forever is because we're brute forcing it, right? So we have 64 characters or more, and we have to iterate through all of them, which is I don't know how many options, but it's a shit ton. And what we're doing here is we're printing it out. Remember how I said we're going to print it out over time? So if I scroll this down a bit, what we're doing here is we're iterating over it and we're printing it out. So this is the piece here. So we're finding W, and we're like, okay, W's there. Okay, N's there. So I'm going to add N to W here for our password and a character. Okay, now I have a capital N, so I'm going to add capital N to my lowercase n. I have a capital I. I'm going to add my capital I to my uppercase I. And we're going to keep adding this to the list, which is listed up here. Remember, it's up there, up here somewhere. So that's what's happening right here. We're iterating over it. We already have our filtered list, and we're working with our filtered list to find out what the password is. So eventually, it's going to get to a point where it shows you something like this. And this is our password for 15. And, magic is beautiful, and that is the answer. So we're not going to finish this. I'll let it run. But internet, that was 14 and 15. I enjoyed it. Hope you enjoyed it. I learned a lot, and I will see you next time.